Today we will be learning how to reduce a switching equation using the Boolean algebra. The importance of reduction of switching equations using Boolean algebra is that to eliminate the redundancy. So redundancy is nothing but a repetitive information that we will be removing. So in order to understand the basic design flow of reducing a switching equation, first let us consider a equation as f equal to x y bar z plus x y z. If you look at here the expression has two minterms. One is x y bar z and another minterm is x y z. So in these two minterms we need to remove the redundancy, for which the regular process, what we'll do, it is x common terms we will be taking, that is x and z as the common terms. So this is minterm 1 and let me represent the minterms as 1 and 2. So in minterm 1 x and z, in minterm 2 x and z are common. So let me take those two terms as out common variables, and if you are going for the uncommon variables y bar and y, I'll be retaining in the equation. So once you go for the reduction, it is x z y bar plus y. It is already we know that its value is 0 and its value is 1. So hence the reduced expression is xz. Similarly, if you go for one more example, that is, let me take one more equation, switching equation as x bar y z bar x bar y z, another term x y z bar x y z. This is another next switching equation we are considering. In this switching equation, so we have basically four terms, min terms 1, 2, 3, 4, and these four min terms have to be reduced to an minimal expression. When you are reducing the minimal to an minimal expression, we need to remove the redundancy. So the regular procedure how we adopted in the above expression, that is not possible because the number of terms we have more, so hence we will go for comparison method. So by comparison method, how do we reduce these min terms? So let us see. In a comparison method, basically the subsequent min terms will be compared. So hence, if you go for the first step, the process will be as follows. Compare terms 1 and 2. When the first term and the second term has been compared, it is x bar y is a common factor, whereas z bar and z are the uncommon variables which exist between both the terms. So hence you can see that the output will be x bar y after applying the Boolean law, because Boolean law says that z bar when it is odd with z, always the value will be equal to 1. Similarly, using the same comparison method, the next step, compare the minterm 1 with 3. When it is compared with 1 with 3, here you can see 1 is x bar y z bar and the third term is x y z bar. So therefore here you can see that y and z bar as the common variables, and x bar and x will be left out. So hence from the comparison rule, when the first term and the third term has been compared, it is y and z bar. In the next process of comparison method, compare the first term, compare the term 1 with 4. Once the first term and the fourth term has been compared, so after the comparison x bar y z bar with x y z, so there is no two common variables which can be removed out and Boolean law cannot be applied. So therefore you can say that it is not possible with to remove redundancy between term 1 and term 3, term 4. So hence we cannot compare. This is the first stage of comparing the first term with the all subsequent terms in order to see that there is a redundancy to remove. Similarly, we have to consider in the second stage, compare second term 2 with term 3. If term 2 and term 3 has been compared, so it is not possible for us to remove any redundancy because x bar y z, x y z bar, so hence not possible to remove redundancy. Similarly, the second step, compare the term 2 with term 4. When term 2 and term 4 has been compared, we can see that x bar with yz common, x bar in one term will remain and x in another term will remain. So hence we can apply the Boolean law. So hence the redundancy removed term will be left out is yz. Similarly, if we go for comparing, so now the second term has been compared with the third term. Again, second term has been compared with the fourth term. So since all the subsequent comparisons of the second term has been over, the comparison rule has to be applied to the subsequent term, that is term 3. Now in the comparison, in the third stage of comparison rule, term 3 compare with term 4. After comparing term 3 with the term 4, we are able to see term 3 and term 4. So xy is a common variable, whereas z bar and z can be removed by applying the Boolean law. So hence it is xy. After applying the comparison result, finally how do the final result of the uh, comparison method will be considered. So for which, so consolidate now the output of or the results of all the comparison methods are all the compared terms outputs. So hence the final output P will be equal to, from 1 and 2 comparison we got x bar y, and 2, 1 and 3 comparison we got y z bar, whereas 1 with 4 it is not possible. Similarly 2, 3 it is not possible, and if you look at 2 with 4 it is yz. Finally the term 3 with 4 we got xy as the final. Again, the process should not be stopped at this point. Again, the terms, in between terms, the comparison has to be done. Again, let me represent one. The comparison method has to be repeated until between all the terms, the redundancy to remove. In the comparison, while applying the comparison method, please do remember, in the comparison method, between any two subsequent terms, when the redundancy is getting removed, only one variable we have to check for a difference. So again, the comparison rule, if I apply, so here compare 1 and 2. 1 and 2. Is it possible with this 1 and 2 to remove the redundancy? Not possible. So between 1 and 2 terms, min terms, are the product terms. Now it is not possible for us to remove any redundancy, because there is no variable to which we can remove the redundancy. Similarly, compare 1 with 3. Compare term 1 and 3. If 1 and 3 has been compared, it is also not possible. Whereas with 1 and 4, by comparing 1 and 4, if you are looking x bar plus x with y as a common variable. So therefore this leads to y. So the first term I have compared with the last term. All comparisons in the first stage of comparison with the second stage of equation, we are able to see y as the output. In the second stage of comparison method, again take the second term, compare with the third term. Yz bar, compare 2 and 3. Terms 2 and 3. Here in this case, you can see that y as in common, z bar and z will be removed because of Boolean laws in digital fundamentals. So we will be getting as y. Again, if you are comparing with 3 and 4, then the comparison of 2 and 4, if you are looking at, so it is not possible. So it is further not able to reduce it. So the last step of the comparison is compare 3 and 4, terms 3 and 4, yz and xy. So here also not possible. So hence the final result of your switching equation, given switching equation, after reduction will be equal to the second stage comparison method output. So y plus y. So hence we know as per Boolean laws, y when it is added with same variable, the output will be only the variable, single variable. Okay. So this is how a reduction of an switching equation will be done using Boolean algebra. Thank you.